Hello, my name is Kirubel. I will explain how I find the intersection and union of two sets without using the built-in method. So I will describe the approach, the step-by-step process, and I will notify the time complexity and test scenarios. So I will begin with the intersection of two sets. So my overall approach will be to find an intersection. So I will loop through one set and check whether the element exists in another set. If I find one, I will add to the result set. So first, I will choose one set to iterate over. So for each item, I will set a check if the second set contains the same item, and yeah, if it does, I will add that item to the new result set. At the end, I will the result will contain only the elements that appear in both sets. No duplicates are going to be there, and this is a step-by-step approach. So when I move to the time complexity, the big O performance, the sets are implemented when they are implemented in a hash-based structure, like Hashset. It's going to be a constant time. So overall, the all time complexity is going to be the big O n, where the n is the number of elements in the result set. So um, my test case will be I will try common elements first, which were in both sets, and also I will test uh, that are not common elements, and also I will test if the test is empty. And also my other test scenario will be if the sets are identical or equal. I will test these scenarios. When I move to union of two sets, so my approach will be to add all elements from both sides, but avoiding duplications. Um, so since sets they couldn't accept duplication, so this is how I will do first. First, I will create a new other set. So I will loop over from this first set and add every element without any problem. But on the next element, when I loop through over, I will check if the elements um, are in the new sets. If they are, I will ignore it. Finally, the result will contain the unique elements of from both sides. This time performance also is going to be with a hash set. It's a constant time eventually. The total time complexity is going to be the big O n plus m. Let's say that's an m, where n and m are the size of two sets. That's the time complexity. And also, my test scenario will be uh, um, I will test if there are overlapping between elements, and also I will test sets that contains completely different items, and also my scenario is gonna be one of the sets is empty, the other is full of elements. This is gonna be my test scenario. Maybe it's gonna be both sets are empty. I will test this. This is gonna be my test cases. So this approach avoid the built-in methods, and it seems also efficient, and that's good. Thank you.